Out in space, there are places where gravity's influence is so intense that not even light can escape. These are known as black holes, objects with extreme gravity caused by extreme density that have an extreme influence on everything that gets too close. Often the subject of science fiction, black holes are science fact, but they're often misunderstood as black holes aren't exactly holes. So let's investigate. What are black holes?
A black hole is an object so compact that not even light can escape its gravitational potential. That's exactly where the name black hole comes from. It's black because it emits no light.
Black holes used to be just a mathematical curiosity, but in the 1950s, 1960s, we actually realized they're out there in the universe. We know that there are black holes that have stellar masses that are born from the gravitational collapse, from the death of stars. We also know that there are much bigger black holes that sit at the center of galaxies.
So they are stars at the end of their life, bigger than the sun, more massive than the sun, but they run out of their fuel and they start to collapse because gravity squashes them. And so they collapse, as far as we know, to a point, right, essentially an infinitely dense point, that there's a region around it from which light can't escape. That's a black hole.
But what happens as you travel towards one? Let's explore the different parts. First, you'll reach the event horizon, a point of no return where gravity pulls you in forever. Closer in, you'll find the swirling accretion disk, superheated gas and dust feeding the black hole. Finally, at the center lies the singularity, a place where physics breaks down as we know it. It's a mystery even to science.
There's all sorts of ways of finding black holes. You can find them from their emission at certain wavelengths, like in the X-rays. We can see them in the optical and the ultraviolet and the infrared. Various NASA missions have been great at finding black holes. And then more recently, the really exciting way to find black holes is when two black holes merge, they create ripples in space-time, and you can detect that from gravitational wave observatories.
A couple of years ago, we had the first image of a black hole, and that looked like a donut. But the donut was the matter around the black hole, and the black hole itself was just a dark, ominous void at the center.
Black holes have extreme physics going on around them, all sorts of crazy things happening. Your perception when you get very close to a black hole is that time is slowing down.
If a human traveler got too close to a black hole, they would first fall through, feeling nothing, until the point of spaghettification, where they would be stretched into a cosmic noodle.
When a star is passing by a black hole, one side of it gets greater gravity than the other, and so you get this very stretching effect. And so the star can be torn apart. This is what's called a tidal disruption event.
What could be inside of a black hole? The most commonly accepted answer is a point of infinite density that we cannot really describe well. At this particular region within a black hole, all of our theory of general relativity breaks down.
Thankfully, as humans living on planet Earth, we will never be close enough to any black hole, including the supermassive black hole at the center of our own galaxy, to ever be in danger of falling in.